Okay, we're going to solve systems. So that means a couple of two or more equations at once. We're solving together. So let's look at this system right here. We've got two equations, x plus 2y equals 4 and 3x minus 2y equals 4. And the question is that point, that xy point, a solution? Well, let's plug it in the first equation here and see what happens. So that would be 4 plus 2 times 0 equals 4. Is that true? 4 equals 4, that's true. Let's plug it into the other equation here and see what happens there. So if we do this one, that'd be 3 times 4 minus 2 times 0 equals 4. And if you simplify that, that's going to be 12 equals 4, and that's not true. So because that point is only makes the first, so that this statement is true, this equation is false. That point, when you substitute in, makes it false. So it's only true for one of the two equations, so that's not a real solution to this problem. Let's try the point 4, 4. Let's try it in the second equation first. So 3 times 4 minus 2 times 4 equals 4. Well, let's see if that's true. 12 minus 8 is 4. 4 equals 4. That's true. So we're good on the first one. If we check the second one, that would be 4 plus 2 times 4 equals 4. Well, that's clearly not true. That's false. So this is not, that point is not a solution to the system. Both equations have to be true in order for that to be a solution to the system. Let's try one more here. So if we do this one, this would be 3 times 2 minus 2 times 1 equals 4. 6 minus 2 equals 4. That's true. And here this would be x, which would be 2 plus 2 times 1 equals 4. So 2 plus 2 is 4. That's true. Because that's true for both of them, that is true for the pair. Just so you can see a picture of this, this would look kind of like this, right? So if you saw a picture of this, you can see that the graphs go through that one point. And so the solution to that system is the ordered pair 2, 1. If you plug it in, it works for both equations. So I want your answers. Sometimes maybe in the past for systems, you've probably done a little bit of this. You might have said x equals 2, y equals 1. That's not how I want your answers. I want your answer written as an ordered pair. I want you to be thinking about this graphically. So I know that still x is 2, y is 1, but I want your answer written as an ordered pair, really for this whole section when we're talking about systems. Let's see, just a second. Okay. So there are two methods of solving a system, two main methods, I should say, not the only two methods. And you're probably familiar with both of them, to be honest with you. So it's very possible you've done both these methods before. So, but this first method, substitution, let's try that one first. So with substitution, oops, you want to solve one equation for a variable. Okay, and then so let's do that. Let's take this one and solve it. So we get x, if we add 2y to both sides, equals positive 2y plus 5. So then we're going to take the second step is substitute into the other equation, Don't substitute back in the same one. That won't work out too well. So what that means is you're going to take this guy, that's really x, you're going to plug it into the other equation. Right, so everywhere there's an x, you're going to plug in 2y plus 5. So it would be 4 times 2y plus 5 plus 3 times y equals 9. So wherever it says x there, we're going to plug in a 2y plus 5. Then we're just going to solve that. So, and you, again, I think you've probably done this method. So distribute there, you get 8y plus 40, plus 20, sorry, plus 3y equals 9. So 11y, subtract 20 equals negative 11. Divide by, running out of room here, divide by 11, you get y equals negative 1. You're not done with the problem. You've got to plug that back in to get x. I would plug it back in right here, right? Because we've already got this one solved for x. So this will be 2 times negative 1 plus 5. That's negative 2 plus 5, which is 3. So our ordered pair, our answer is going to be 3 comma negative 1. Again, I want you to write your answer as an ordered pair. Let's try elimination. Again, I think you've probably done this method before. It's my strong guess. But we're going to do elimination, show you how to do it. So you have to line up. So first step is line up all the variables, line up everything, right? This one is, it's already, the x's are lined up, the y's are lined up, the equal signs are lined up, the constants are lined up. So everything's lined up. I like to get one variable the exact opposite in the two equations. And so usually you have to multiply to do that. Let's see. So this one, I guess if you multiply the top equation by, you could do negative 4, right, to get rid of that x there. So the top equation would become negative 4x if I distribute plus 8y equals negative 20. Everything's multiplied by negative 4. Ooh, negative 4, that makes it positive 8y, doesn't it? Careful, that negative distributed to every term there. The bottom equation stays the same. The second equation is the same. 3y equals 9. You're going to add, because they're exact opposites, the x's should go away. They do. You get 11y equals negative 11. Divide by 11. This looks a lot like the other one. Y equals negative 1. You're going to plug that back into one of the equations. I might do this one just because it looks like a little bit less work. So x equals 2 times negative 1. I guess, plus 5 if you solve that for y. So we get x equals negative 2 plus 5. So x equals 3. Your final answer is 3 comma negative 1 as an ordered pair. And that's elimination. You could have also, just so you know, like let's say we wanted to get rid of the y terms. You could have multiplied the top equation by positive 3. That would have worked. The bottom equation, you could have multiplied by 2. That would give you negative 6 and positive 6, which would eliminate the y's and then go from there. So there's other ways to do it. Sometimes you don't even have to multiply. It's kind of nice. Go ahead and solve these both for y and graph them in your calculator. So this is kind of stuff I just want you to see the same system solved a different way. Right, so that first one's pretty easy to solve for y. So x equals 2y plus 5. Second one, I'm going to move that over. So it'd be 3y equals negative 4x plus 9. Divide by 3, divide by 3, divide by 3. Get y equals negative 4/3 x plus 3. So get your calculator out, and we're just going to go to a graph page. So go to the graph icon there. 2y. Oh, we have to solve this one for y, don't we? Oh man. So this is solved for x. So if you want to solve this one, you have to solve for y. So let's finish that off. So we get, let's start where we, so I guess we can go to x minus 5 equals 2y. And then divide by 2, divide by 2, divide by 2. So you get y equals 1/2 x minus 5/2. Okay. So we finally solved for y. So that would be 1/2 x minus 5/2. and hit tab to open up the entry line. Then we get negative 4/3. Oops. 4/3 x plus 3. Okay, so we've got these two functions, they cross. I like to go to geometry. You could go to analyze graph, points and lines, intersection point, just click the two graphs and it'll find the intersection point, which seems to be 3, -1, which is the same answer we got. And so that's where the two graphs cross. It's where they're equal. You can also see that in the table if you wanted to, but that's just another way of viewing that one. Let's try this one. This looks good. So again, you can choose, you really have to know how to do both methods. So I would know, because on a test or quiz, I'll say solve this one. I might say solve this one using elimination, solve this one using substitution. Usually there's one method that looks a little better than the other one. This one just looks like a tough problem, so it's not going to be real easy to solve. Although elimination looks like a better fit here if I had to choose one of them, and I got to choose one. So I would multiply by 2 to get the same x's here. So this would give you negative 6x plus 10y equals negative 12. And down here it'd be 6x minus 10y. Ooh, this can be interesting, equals 12. It's not what I expected. I'm going to add them together. The x's go away, the y's go away. I guess I just have 0. And negative 12 plus 12 is 0. Does 0 equal 0? Yes, it does. And so, in fact, for this one, what this means graphically is these two lines are the same graph. Like it's the same graph on top of each other. So there's an infinite number of solutions on that. So we say, in this setting, we say infinite solutions. Whenever 0 equals 0, whenever all the variables go away. So that happens sometimes. By the way, if the answer was, if I'd gotten to the end, it was something like, 0 equals 4 or something. That's not true, so that would be a no solution problem. And graphically speaking, that would mean two lines are parallel lines, right? So if you get two things that are not equal, it means the slopes are the same. They never touch, they never actually do that, but they do that. Try this one. So let's try this one with substitution. We just did elimination, so let's do a substitution. And it's kind of set up for it, right? If I were to choose, I would choose substitution. So for this one, again, we're just substituting in. So I plugged that in everywhere there was a y. I plugged in -1/2 x plus 4. And so then we're just going to distribute here. So x minus 2 times 1/2. Half of 2 is 1. So 1x plus 8 equals 1. Ooh, this is weird. X minus x is 0. So I just have 8 equals 1, which is certainly not true. What this means, again, graphically, means these two do not have the same y-intercept. So they both look like they have a negative slope of -1/2, but they don't cross at the same spots. So the answer is no solve, no solution, the empty set. Good, that was a quick lesson. Again, that's more of a review because you've probably used both those methods before. So go ahead and have at the homework. Thanks.